A joint density function is given as follows. Find the covariance of x and y. Now, joint density function has to double integrate to 1 if it's continuous. If the variables involved are continuous. Otherwise, for discrete, the double sum has to equal 1. So the double integral in general is from negative infinity to infinity for both. So the PDF has to double integrate to 1. So here the PDF is kx, and the range is 0 to 1, 0 to 1 for both. And so the integral, it doesn't matter which order you do it. If we do with respect to x first, it gets kx squared by 2. X goes from 0 to 1, so that be k by 2, and then we do it with respect to y. So it would be k by 2 times y, and then you substitute the limits. The whole thing, the whole double integral always at every step has to be equal to 1. And here when you substitute the limits, you just get k by 2 times 1 minus 0. So k equals 2. Now covariance of xy is what we have to find. Covariance xy equals expectation of xy minus expectation x times expectation y. Expectation xy is the double integral of xy against the PDF. So xy and the PDF was 2x. Remember, it was kx, and we found k to be 2. So once you integrate, first we'll simplify. If you're doing respect to x first, so you will have 2y as a constant, and then x squared integrates to x cubed by 3. And you put the x limits, get 1/3, so 2y by 3. And that's just a one variable integral. When you integrate, eventually we get 1/3. Similarly, e of x is x times the PDF and double integral of that. And with all said and done, it's 2/3. Ey is the double integral of y against the PDF. And so we end up getting a half. Now covariance, as we said, is e of xy minus excy, and we substitute the values of all these are the three things, this, and this, that we calculated above. We get 0. Now there is a shortcut for this particular problem, and that shortcut is always available for a covariance when the PDF, so there are two conditions needed to apply that shortcut. One is that the PDF should be, you should be able to separate out the PDF as a function of x times a function of y. So remember, this PDF came out to be 2x, which can be written as 2x times 1. So that's a function of x times a function of y. And yeah, so we could write it as if you can write it as g of x times h of y, and here g of x was 2x, h of y is 1. So you see, this is just a function of x, this is just a function of y. And I mean, in other words, you should be able to separate out as a product of one variable functions alone. So this is just one variable function. This is just one variable function. And that's one condition that you need. And the second condition you need is that the domain should be a rectangle. So here the domain was 0 to 1, 0 to 1, which is a square of sides 1, 1 here and 1 here. So the way you recognize a rectangle is that all the limits are constants. If all the 4 limits are constants, then it's a rectangle. This one is a square, but that's also a rectangle. So if the domain is a rectangle and the function can be separated out into one variable functions as product of one variable functions, then actually the two variables are independent and covariance is 0. So if you had recognized by this shortcut, by looking at this, you could right away have said that the covariance here is 0. That's what we got after all our calculations. So you may be wondering that did we just waste our time? No, because this is a minority occurrence where you will have a function like this, where the two conditions of independence will be met. For most of the problems that you will encounter, as you will see that the next few problems we will do not meet this condition, and there you do have to do the work. And so I just did the work, because if I had told you the shortcut in the beginning, you would not have been interested in learning this process, which actually we will need for most of the problems. So the correct answer here was B.